So we have the following differential equation: secant of t times dy dt equals 1, and the initial value y of 0 equals 1. And we want to see if we can solve this with separation of variables. So with separation of variables, we want to get all the y's on the left-hand side and all the t's on the right-hand side. So I think the easiest way to approach this one is first, actually, instead of dealing with secant t, because we want it to go with the dt, let's change that to 1 over cosine t. So we're going to have 1 over cosine t times dy dt equals 1, and now we do have a separation of variables situation. Let's clean this up just a little so you can see it a little bit more obvious. Dy over cosine t dt equals 1. And so basically what I'm going to do is I'm going to multiply both sides by cosine of t dt. Or you could think of it as cross multiplication. You could really skip this step here. I just wanted to show you where it was coming from. And now our variables are separated. So now what we'll do is we'll take the integral of both sides on the left hand side with respect to y, on the right hand side with respect to t. Now the left hand side, let's clean this up just a little so it's not quite so messy. On the left hand side we just have the integral of dy, or we could think of that as 1 dy. So that's just y. On the right hand side it's just the antiderivative of cosine of t, which is sine of t, and anytime we're doing an indefinite integral we want to have a plus c. And because we have an initial value problem, we're going to be able to solve for c. Now, a lot of times when you see y of 0 equals 1, you'll just say, okay, well that means my constant is 1, and it will be in this case, but it's a good habit to plug those in and solve for c, because that's not always going to be the case. So if we plug in 1 for y, because we know that y is 1 when t is 0, that's our initial value, plus c. Now sine of 0 happens to be 0, so this works out nicely, but had this been a cosine, we couldn't just plug 1 in for c. We get c equals 1. So our unique solution is y equals sine of t plus 1.